Hey guys, so this is my new video. I was getting a lot of requests from people asking if I could also make a corresponding nut to the bolt. So not just external threads, but also internal threads. So this video is going to cover both of those, and it's also going to cover some of the theory behind how to make an actual true isometric thread profile and some of the rules and conditions behind that. If you guys have any questions or comments, definitely leave them in the comments below. Subscribe. I noticed that I've been getting lots of subscribers lately. That's fantastic. I'm glad that I'm providing content that you guys are finding useful. So definitely continue to do that. Also, if you've got any content that you'd like to see me post on here, some tutorials or reviews or whatever, definitely let me know and I will really try to provide that. Okay, so on to the lesson. So before we begin, there's a few things you're going to need to know about your threads. So in this case, one of the most important things you need to know before you begin building your profile will be what's the thread pitch. So thread pitch, if you don't know, it is the distance between the threads. So dead center on this one to dead center on this one. And in this case, it's 6 millimeters. You know that because it's M64 by 6. So it's M64 millimeters by 6 millimeters. And the second number is always the thread pitch. In metric, that means that the distance between the threads is 6 millimeters, whereas in standard, it goes in threads per inch. So the next important things that you're going to want to know is your major and minor thread diameters. So for the internal threads, or the nut, which is represented by the two outside profiles here, the major thread diameter is from the lowest point here to the lowest point here. So that's the largest distance within that nut. And that's taken in a straight line directly across, not diagonally. So for the minor thread diameter, that's taken from these two high points, but directly across, not diagonally. Same idea for your external threads or your bolt. Major thread diameter is taken across the tops of the threads. Minor thread diameter is taken across the valleys of the threads. And also taken in a direct line directly across, not diagonally. So one of the things that you might have noticed is that for the internal threads, the major diameter is the same number as the threading number. So M64, and it's a 64 millimeter major thread diameter in the internal threads. So you'll also notice that the major thread diameter is 63.5 on the external threads. That's only a half a millimeter difference. So you'll notice that it's already got a half a millimeter of clearance for this thread combination. Same thing with the minor thread diameter, 57.5 versus 57. Next thing that we need to know is how you're going to array your thread profile. So I like to do it in sections of 12. So you take your circle, you divide it by 12, which gives you 30 degrees per segment. You take your pitch, you divide it by your number of segments, and that gives you 0.5 millimeters of vertical offset per array segment. So now that we have all the preliminary information, now we can proceed to actually building our threads. So now that we have all of our math and all of our profiles set up, we can move on to making the actual threads themselves. So we're going to start by doing the external threads on this bolt. So first thing, I will clear my workspace. I reorient on top of the work, and I like to have my linear snap at 0.5 and my angular snap at 5 or 10 if it's available. First thing you do is you grab the sketch tool, and then you use the major and minor thread diameters to make some circles here. So 57 for the minor and 63.5 for the major. Next, you grab the polyline tool, but you don't want to associate these lines with the actual circles. So click outside the circles on the grid and then go in. And from that center point, you work your way out. So the first dimension that we want to do to line it right up with the minor diameter circle is you want to go to 28.5. That's half of your minor diameter, which is 57. So enter, and then we want it to be exactly 90 degrees, enter. So then to unlock those, you hit escape, tab, escape. So then they're both freely moving now. So now it's going to be half of the large diameter, the large dimension on the back, so that 4.5. So that's going to be 2.25 because I'm starting in the middle. Oh, that's on the angle there. So tab to switch, 2.25. enter to lock it in there. I want it to be 180, so I do want to lock that. So then same thing, escape, tab, escape, to make that free again. So the dimension, as we went over before, is 3.75, and since I mentioned that they're all 60s, we're going to go with 60 degrees, enter. So this dimension here is 0.75, and we do want it to be 0 degrees, so we'll go with that. Now it's 3.75 again, enter, and we want that to be 60 degrees, enter. So then we want to clear those again so it makes it free, and then we just tie it right back in again. You can see that that goes straight to 180 degrees and 2.25 millimeters. That's perfect. And you click. So now you can see we have our thread profile right here. So the next thing we need to do is reorient it. So click on that, go to move, and since you can see this is kind of wonky, it's on a bit of an angle, so we're going to change the pivot point. So click on start reorient, bring it right over here, click, stop reorient. So now you can see it's actually in the planes that we want to be using. So we need this to be perpendicular to our circle, so you just change it to 90 degrees, hit enter, and now that thread profile is exactly where we want it to be. Next, we start arraying that profile. So that we do that by clicking on the profile itself, then use Control C to copy and Control V to paste. So right now they're overlapped. So all you have to do is you click Start Reorient, put it to the center, stop Reorient, and then you bring it over by 30 degrees, like I mentioned before. And since we're going to be doing right-hand threads, we're going to move that profile up by 0.5 millimeter. Or sorry, rather, down by 0.5 millimeter. So then you hit enter, and since that's still highlighted, you do Control C, Control V once more, and you just want to keep doing that. You reorient it, then you move it over by 30 degrees, then you pull it down by 0.5, and you just keep doing that. So that's why I changed my linear snap to 0.5, is because then you don't have to mess around with typing in values, you don't have to mess around with anything. So you just keep doing copy and paste, and then it makes it super easy to do. You can also change your angular snap to 15 if you want. That'll make it quicker too. So I've just unhighlighted that. Okay, so copy, paste, change reorient to the backside here. We'll see how it goes 15 per now. So we'll go 30, then you go down that 0.5 millimeter, enter, copy, paste. Oh, whoops. Copy, paste. Start reorient. Put it to the center. Move it over by 30. Move it down by 5. Enter, copy, paste. And so you can see you just keep doing that over and over until you've done 12 segments. The last one, I think I hustled through it and I cut this section out, but just with the idea of trying to show every single step, I'm just going to do it the whole way through. So same thing, 30.5. So it's not really a lot of work, but it can be a little tedious and maybe a little time consuming. So we just got the one more. So just to confirm that we did all this right, you can see they're all spaced in the middle there. Just to make sure, we'll actually measure from this point to this point, and that is the 1.5 that it should be. So that's perfect. So now we actually build the threads. So you just have to select all your thread profiles. You do that by clicking on the first one and then hold the shift key while you click on all the rest. So now they're all highlighted, and now you can use the Loft tool. So the Loft tool just kind of looks like a hollow tower here. So once you click that and they're all highlighted, you can see that it sends your profile around to make it all one piece. To get a better view of that, I'll hide the sketches. So now you can see just that thread profile. That's your one single thread. So next you take that thread profile, or the thread that you just made there, and you just copy and paste it up as many times as you want. So copy, paste, and then you want to move that up since you know that your thread pitch is 6. Super easy, just move it up by 6. Grab the degree one there. Okay, so I think that should be good enough there. You can go as many as you want. So next is I'm going to bring back those sketches, and then I'm going to actually make a cylinder here. So you're going to take that and you're going to extrude that from that circle from the minor diameter, extrude that all the way up. It's going to automatically go straight to the cut function, but you want it to be merge. Enter, and then same thing on bottom, bring that down, extrude. So, but this one you want to bring it down until it's just midway down that first thread profile. So one more. So see you go down 6 millimeters, so that's your one thread pitch. Oh, I accidentally let it do the cut function there. So you extrude downward, -6. Don't forget to use the merge. Okay. So now it's starting to look a little bit more like a bolt. So just like the last one, I like to do kind of a clean lead in and out of that bolt. So since this one's already 60 degrees, we're just going to go to that first initial one, the first initial profile, and I'm just going to carry that 60 degrees away from it. So 60 degrees there, and then you can just kind of be arbitrary from there. It's not going to hit anything else, so just do 90 and then there. So now the main thing is that you have that 60 degrees, so you maintain that angle following that thread all the way down. It just kind of gives it a nice smooth lead in. So now what you do is I'm going to remove, hide solids. I'm going to get back on top of this drawing because I need to make an axis. So I'm going to just start from the center point there, 180 degrees. It really doesn't matter how long it is, so I just hit escape because I only need that one line. And then you do the exact same thing I did with the thread profile. You stand that up on end, go to the move function, you change the pivot to the end, and then you bring it up to 90 degrees so it's perpendicular. That becomes your axis for everything that you're going to revolve now. So I bring back the solids and meshes, and then I click on that profile. We're going to use the Revolve tool. Then I click on that as the axis and 360 degrees. Enter. So that cuts a big hole in there, and I'll get rid of the sketches, hide sketches. So now you can see you've got a nice smooth lead in on that thread. So that's gonna thread in really easily and cleanly. Next, you want to make the head of the actual bolt. So sketch polygon, click in the center, drag it out. So I already looked online, and the actual size of the bolt head is 95 millimeters for a M64 by 6. So I'm going to go straight to 95 millimeters. Oh, so I got to do half of that. So half of 95 is 47.5. Enter, enter. So this we're going to extrude up and extrude down. So just extrude it down far enough that it covers the missing threads there. So that's good. Merge. And then extrude it up until you're satisfied with the thickness. So let's make it, I think that looks fine. So there's your bolt. You can see that it's got all the characteristics. It's got the thin piece there, the thick piece there. Thread pitch is 6 from here to here. That's a pretty nice looking bolt if you ask me. Okay, so on to doing the nut. So next I make the nut. So I'm gonna bring back all the sketches, and then I will make the nut over here. So start the exact same way. So reorient on top, you get your circle tool, and then you make your major and minor thread diameters for that, for the internal thread. So those were 57.5 and 64. Same thing, polyline, click outside the circle, except this time we're going to go to the outside. So that's 32 to the outside, because that's half of 64. You still want it to be 90 degrees, enter. But see how we're starting the outside? Because you have your thread profile reversed. So the skinny side of the thread profile goes towards the center. So just like before, you want it to be 2.25, enter, 180. And then come over and it's 3.75. You want the angle to be 60. Then you come down by 0.75. Want your angle to be 0. Then you come over and your dimension is 3.75, with your angle being 60. And then you bring it up to here, same thing, 2.25, and your angle is 180. Exit. Okay, so now we have our thread profile. The one thing we have to do different here is you move to the trim tool, click on it, then you click on here, and then you want to remove that section from your thread profile. Enter. Same thing as before, you want to click on that thread profile, go to the move function, reorient to the center. .90 degrees, enter. Perfect. So one thing that you guys have probably noticed is that whenever I'm making moves, I'm holding the shift key. I just have it set up that way because when I'm using Fusion or other design software, that's how it works. So when you make a move, you hold shift and you move around with the mouse with the left mouse button. You don't actually have to. That's not native in 123D design. I just did it so it's the same controls for all of them. So that probably won't be the case for the way you're running it. So then you click on this profile here, copy paste. So this one I'm actually going to accelerate just because you've already seen how I do it, so I'm not too worried about people getting lost on this one. So let's make it go faster. Profiles are arrayed. We're just going to double check and make sure that the spacing is proper here. Okay, 1.5. So now just the same as before, just start with the first one, hold shift, and continue to click around and grab all the arrayed sections. Now click on the Loft tool. So now you can see you've got your internal thread there. Kind of looks like a helicoil. Show solids, show sketches. So same thing. Just copy and paste a bunch. You're going to want this to be a little on the tall side, just to make it easier for when you actually make the hex. Oh, oops, there we go. Because you can always erase ones that are too tall for your nut, or for the internal threads that you want to do. So I think that should be good. 1, 2, 3, 4, 5, 6 threads. That'll be alright. I'm sure there's an actual formula for how many threads are supposed to be in there and how tall the actual nut's supposed to be, but I'm just going to use arbitrary values. So one thing that I had forgotten to do, I just realized that now, is I didn't combine all the threads and merge them all into one. So if you click the merge function for here and you click all the individual pieces that you made, so all the threads, the cylinder, the head, now it all makes that bolt one piece. So we're going to not skip that step now, and we're going to do merge all the threads at once. So now this is just one big helix. So we'll get rid of the solids. Same thing, get on top of our drawing here. Sketch polygon. Same as before, it's got to be 47.5 to match. And then you just want to extend this up. So extrude. think 25 should be adequate for the actual thickness of the nut. So that's what we'll go with. Okay, so now the one last step left to do is to clear off these threads that are poking past either side. So the way I do it is I'll use the project tool, and then you click on the face of this side, and what it does is it projects an actual sketch of that drawing onto that surface, but it also projects the center too. So you just click on it, you extrude it up, and then it'll cut away the threads that are poking out past. Same thing with the other side, but before I do that, I don't want the old sketches that I put in here to interfere with what I'm about to do here, so I click hide sketches. So then this one sketch that I make will be the only sketch in the environment. So then you grab that circle there in the center, same thing, extrude it out, hide sketches, and there's your nut. So this is built to actual metric ISO thread specs. So in theory, as long as if you wanted to print out either of these, it should thread into an actual metal counterpart, as long as you make up for plastic shrinkage factor when you're 3D printing. So that's it. That's the whole tutorial. I hope that this was more information than you guys could want, and you can just pick and choose whatever is going to work best for you. Again, if you like the video or you have any suggestions, let me know. Put them in the comments below. Thanks everyone for subscribing, and yeah, I hope that this has been helpful. Thanks.